You know, when you think about the most productive factory on Earth, what comes to mind? Cars? Smartphones? Well, what if I told you it's actually inside you? Right now, it's churning out trillions of new cells every single day. It's an absolutely incredible, nonstop process, and we're about to take a look inside. I mean, think about it. Trillions of new blood cells every single day. Where do they all come from? Your body is constantly getting rid of old, worn-out cells, red cells, white cells, platelets, and replacing them. That's not a small job, right? It's this massive, massive logistical operation. So what's the secret? How does our body pull this off? Well, the answer has a fancy scientific name, of course. It's called hematopoiesis. And that's really just the term for the whole process, the production, the differentiation, the development of all your blood cells. For the next few minutes, think of it like we're getting an exclusive tour of the factory floor where all this magic happens. All right, so here's our game plan for the tour. First, we'll find out where this factory is even located. Then, we're going to meet the master cell, the one that holds the blueprint for absolutely everything. After that, we'll check out the two main assembly lines, get to know the managers calling the shots, and finally, we'll wrap up by talking about why all this is so crucial for your health. Okay, first stop on our tour, the factory itself. Where is this production hub? Well, what's fascinating is that the address actually changes depending on how old you are. When you're a tiny fetus, this whole process actually kicks off in a place called the yolk sac. Then, for a few months, the liver and spleen take over the job. But by the time you're born, the bone marrow steps in and becomes the primary site. And as an adult, well, the production gets a little more specific. It's concentrated in the marrow of your central skeleton, so we're talking your vertebrae, your ribs, your sternum, and your pelvis. That becomes the permanent headquarters for your body's blood cell factory. All right, now it's time to meet the CEO, the master architect, the most important player in this whole operation, the one cell that starts it all. And here it is, the pluripotent hematopoietic stem cell. We just call it the HSC for short. Now that word, pluripotent, is key. It basically means this one cell has the incredible potential to become any kind of blood cell. Seriously, every single cell in your bloodstream, red cells, white cells, platelets, you name it, every single one can trace its family tree right back to one of these master cells. So what makes these HSCs so special? Well, they have two jobs that seem kind of contradictory, right? On one hand, they have to do what's called self-renewal. That means making perfect copies of themselves, so the factory never ever runs out of the master blueprints. But on the other hand, they also have to differentiate. That's when they send one of their daughter cells down the assembly line to start the journey of becoming a specialized, mature blood cell. It's this beautiful, perfect balance of preserving the original blueprint while constantly using it to build new things. And get this, these master cells are unbelievably rare. How rare are we talking? Well, for every 20 million cells in your bone marrow, only one is an HSC. Just one. That scarcity really drives home how incredibly powerful and vital each and every one of them is for keeping this whole factory running for your entire life. But hey, don't let that rarity fool you. Their real power is in amplification. Just think about this for a second. One single stem cell is capable of producing about 8 million mature blood cells after just 20 cell divisions. 1 million! I mean, talk about efficiency on an absolutely mind-boggling scale. Okay, so we know the stem cell can differentiate. But once it makes that decision, where does it go? Well, it enters one of two major assembly lines. This is the first big fork in the road. The HSC makes a choice. It commits to becoming either a common myeloid progenitor or a common lymphoid progenitor. You can think of this as the point where the raw materials get sent to two totally different wings of the factory, and each wing specializes in a completely different set of products. Let's start with the myeloid line. This assembly line is an absolute powerhouse. It's responsible for making your red blood cells that carry oxygen, your platelets that help you clot, and a whole bunch of your key immune cells, the first responders like neutrophils and monocytes. This is kind of like the heavy machinery wing of the factory, churning out the everyday essentials. Then you've got the lymphoid line. This one's a lot more specialized. It produces the elite forces of your immune system. We're talking B cells that make antibodies, T cells that act like commanders directing targeted attacks, and natural killer cells that are always on patrol looking for trouble. If the myeloid line is heavy machinery, this is the high-tech special ops wing. Okay, so we've got the factory, we've got the assembly lines. But who's in charge? Who's making the calls? I mean, who tells the factory, hey, we need more red blood cells because we're at a high altitude? Or, quick, churn out more neutrophils, there's an infection. There has to be a manager, right? Well, there is. Meet the managers of our factory, hematopoietic growth factors. You'll also hear them called cytokines. Basically, these are just signaling molecules that act like work orders. They float around and deliver very specific instructions to the cells on the assembly line, telling them, hey, you, divide now, or you're going to become a red blood cell, and even how quickly they need to grow up. And this gives you a great idea of who manages whom. It's a pretty clear chain of command. For instance, erythropoietin, you've probably heard of it as EPO, is the specific manager that tells the bone marrow to make more red blood cells. Then there's thrombopoietin, or TPO, which orders out more platelets. And GCSF, that's the manager in charge of neutrophil production. Each one has its own very specific job. But what's really crucial to understand is that these managers wear a lot of hats. Let's take GCSF again. It doesn't just show up and yell, make neutrophils. No, it oversees the entire process from start to finish. It tells the early cells to multiply. It steers them down the correct developmental path. It guides their maturation, keeps them from dying off too early, and even helps activate them once they're out in the body doing their job. It's a complete management system, all in one molecule. Okay, so for our final stop on this tour, let's bring it all back to our health. Because this system is amazing, it's elegant, but what happens when the factory breaks down? Yeah, when things go wrong with hematopoiesis, it's serious. A lot of major blood disorders are, at their core, factory problems. Leukemia, for example, is basically the factory gone rogue. It's just pumping out malignant white blood cells without any control. Anemia can happen when there's not enough red blood cell production. And then you have something like aplastic anemia, which is when the entire factory pretty much shuts down completely. But here's the amazing part. This is where understanding this whole system becomes so powerful. For a lot of these conditions, we can essentially reboot the entire factory using a stem cell transplant. By taking healthy hematopoietic stem cells, whether they're harvested from bone marrow or umbilical cord blood or even from the bloodstream after using growth factors to lure them out, doctors can completely replace a patient's faulty system. They can literally give someone a brand new blood cell factory. And that just brings us to this one final incredible thought. This factory, this process, it runs our entire lives, every single moment. And as we learn more and more about the stem cells that start it all and the signals that manage it, the future isn't just about repairing things when they break. The real question, the really exciting question is, what happens when we learn to truly control it?